Let's find out factor of safety and displacement of beam in SolidWorks with the help of simulation tools, and we will learn some basic simulation tools in SolidWorks simulation. I hope you like it. So let's start to create this beam. So first we have to create or prepare a model. So front plane, sketch. Now I am going to activate line tool. And I am trying to draw. Press escape key to out. Again press L key in keyboard to activate line tool. Press escape key to out. Now these center lines are construction line. So I am going to select here construction. Now select these all lines. Mirror about. Select here copy mirror and select these vertical lines. Okay. Now activate line tool and connect and close geometry. Press escape key to out. Okay. Now let's make few important relation. Select these two line and center line, symmetric. These two lines and this center line, symmetric. Important relation. These two lines equal as well as symmetric. Okay. Smart dimension. $100mm, 75, 10mm, angle 100 degree and center to center distance 10mm. Now this is fully defined sketch. Now go to feature and activate, and here keep end condition blind, 600mm length. Say OK. Now for application of pressure and fixing, I am going to create few area. So select this face, sketch. Corner rectangle. No, not corner. Center rectangle. Smart dimension 50. Center to outside 600 divided by 2. Okay. 75. Now go to feature and activate here split line. Now here choose type projection. Projection on this face. So sketch selected. Now here we have to choose a face. Select this face. Say OK. See. Now let's select back side sketch. Now this time corner rectangle. Press escape key to out. 40. 40. Now simply split line this face. Okay. Look. Now let me apply fillet. Constant type 5mm and select these corners. Okay. Now let's try to simulate this material. Before going, first we have to activate simulation tool. Go to tools, select add-ins, or even though you can find drop down add-ins. Here activate simulation. If you activate this one, always simulation tool will be activated while starting SolidWorks. So I am not going to activate this. Simply choose SolidWorks simulation. Okay. Now wait, within a few seconds it will appear here. Now analysis and simulation. Analysis will give you all the tools for simulation. Now go to simulation, new study. Here I am going to apply the name for this project, I-beam. Static. There are many simulation, but we are going to do static. Okay. Now first we have to apply material on this. So here you will see at top apply material. Now here I am going to apply AI SI 304 steel. You will see all the material, tensile strength, everything, it will be here. See, apply, close. Now connections works while it is assembly, but this is a simple part, so we don't need to apply material. Right click and fix geometry. Now we have to fix this model from where this beam going to fix. So bottom we created these two things. See, that's why we created this. From these two ends, this beam going to fixed. Fix geometry. Rest we don't need to do anything. Simply say OK. Now next, apply pressure. How much pressure or load we are going to apply? We are going to apply 1000 kg. So right click, force. Now here first type and split. I am going to work in type. We will keep this tutorial simple. Force, select this face. See, in pink color, this is going to apply on this. That's why we use a split tool to create this area. Now here normal, because the direction is going towards down. Unit I am going to change metric, and here kg force, 1000 kg force going to apply on this point. Okay, we don't need to change anything, say OK. Now right click and create mesh. If we check parameters, mesh is just a mixture of nodes and elements. Now you will see unit you can change, and these are the size of element. See, minimum element, and this is maximum element, and here you will apply minimum number of circles. So this one we will keep default. If you go finer side, you will see too many triangles mesh, and it will take longer time to create or calculate exact result, but finer side gives you exact result. Okay, now see, this is going to calculate and it will create mesh. Now you will see these lines are elements, and the point, all the lines going to connect at one point. These points are node. If you keep more, you will get accurate result, but it will take too much time for calculation. So this is simple. Now what else? Last is simply here you will see run this study. Click, and this is going to run. Now we want to find displacement and factor of safety. Now this is stress. If you right click and animate this, I am going to hold this, let's say 30, play. This is going to calculate, creating frame here. Look, this is clearly okay. Now in practical, you will not see this much of stress because of this. See, deformation scale. This is exaggerated view. It will show you 1245 times of scale. Now comes here, this chart. This is misses. Yield stress. You will see minimum and maximum stress. Right click on stress, chart option. Click show minimum and maximum annotation, say OK. Now look, this is maximum and this is minimum. You will see yield strength. Yield strength is higher than the maximum stress. It means our geometry is near safe side. If you double click on displacement, animate, even okay, just animate. Now it is going to create frame, then it will show you perfectly. Now look, this is also exaggerated view, deformation scale 1200 times. That's why we are able to see this much kind of displacement. If you see here, displacement, maximum displacement, how much? Right click, chart option, maximum, minimum. Now here this is the maximum displacement, right? How much this one? Let's calculate. Look, 10 to the power 02. So 1 divided by 100. How much? 0.01 into multiply 4.28. 4.2821. Look, 0.0 mm displacement. This is a very small displacement. It means our geometry is very near side. Okay, we have in this result section, these are the default results. Even though if you want some more, just right click. Okay, I want to make factor of safety. Now I'm going to keep default. All selected body means if you have any assembly, then you can go for selected body. But for part, I am going to keep all. And here I am going to choose automatic. Say OK. Now look here. Factor of safety 6.7. It means you need 6.7 times of load applied to deform this material. It is this minimum factor of safety. It is really a safe product. Now you can simply talk to your or forward this to sales department or any further department to proceed this material, because this is totally a safe way. Because we applied only 1000. If you applied 6.7 into 1000, this much kg of load at this point, this is going to break. But we apply only 1000, means our product is safe. Okay. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.